Determine the bounded area highlighted in red. Okay, so this area here. Okay, let's use rows this time, not columns. So this time I'm going to use a row with a height of dy, infinitesimally small height, and a width of w. Okay? So dA, my little area of this little row here, is going to be equal to w times dy. Cool. Let's integrate both sides of the equation. So the integral of 1 dA is equal to a. Well, that's actually what I want. I want the area of this whole thing. And, oh, well, now this one I have to work on. So I need to make w in terms of y. Okay, and also my bounds of integration, I'm going to go from 0 all the way to this height here. Okay, because I'm stacking up all these little columns, or all these little rows on top of each other. Okay, and I need to know where to go, what the height is. So I can get the y value by plugging in x equals 3 into here, which is going to be 9. So my bounds of integration will be from 0 to 9. And now let's worry about our w. How are we going to get this w width? Well, I know that this distance here is 3, and I know this distance over here is x, given a y value. Given a y value, I can determine what x is. I can use this equation to solve for x. So x is equal to square root. It's going to be the positive square root of y, because really this is plus or minus, but the minus one is over here. That's the minus. So if I put in a y value, it will give me negative x, right? But here I want to have a positive x because I'm on this side of the equation. So given a y value, I can determine my x value. So the width of this thing will actually be, so what's the width? The width is going to be equal to 3 minus this, because it's going to give me x, which is measured from the x origin. So this distance here is x, right? This is x is 3. So this is from 0, it's 3 out here. So if I given a y value, it will give me this x values from here, but I really want this side. So it's really w is equal to 3 minus x, okay? But instead of putting x, because I need it in terms of y, I need it in terms of y, because that's what my integral is set up. I need it in terms of y, dy. So I need to write down x is equal to 3 minus square root of y, okay? So a little more complicated, but it's getting the width of this thing, right? It's taking 3 minus this function, because remember the function always measures from the origin, right? For 0 to x value. So I will actually want this side, so I'm going to take 3 minus that x value, give me that little guy. Integral 0 to 9 of w, which is 3 minus square root of y dy. Okay, let's just write this a little nicer. Area is equal to integral of 0 to 9 of 3 minus y to the 1/2. That makes it a little nicer to solve. We're going to bring this up here and we'll solve it. So the area is equal to, this is going to be 3y minus, plus 1 is going to be 3 over 2. So it's going to be 2 over 3 y to the 3 over 2. Okay, and the plus c, and then the bounds of integration will be from 0 to 9. Okay, so area is going to be equal to 3 times 9 minus 2 over 3, 9 to the power of 3 over 2 plus c, minus 3 times 0 minus 2 over 3 to the 0 to the 3 over 2. This is all 0 plus c, and the c's will cancel. So all I'm really concerned with is right here. So area is going to be equal to 3 times 9 is 27 minus, this one I might have to look up on my calculator here, 9 to the power of 3. It's going to give me a whole number. I just don't know what it is. So 9 to the power of 3 to the power of 0.5. Okay, 27. So 27 times 2 divided by 3 is 18. So 27 minus 18, that's going to give me 9. So the area is equal to 9. The units will be the units of x times units of y. So meters times meters would be meters squared, or inches, or whatever it is.